Here we're asked to find the derivative of the function f of x, where f of x is defined as the integral from 3 to x of sine of 7t plus 11 cubed dt. So the first thing to notice is that f of x is an accumulation function. This means that it's finding the area under a curve from a number to x. Since it's an accumulation function and we want to take its derivative, we're taking the derivative of an integral from a number to x. We can use the first fundamental theorem of calculus. First fundamental theorem of calculus tells us that when we take the derivative in terms of x of an integral from a constant up to x, we just get back the original function on the inside, but the variable changes from t to x. So this answer is that f prime of x is sine of 7x plus 11 cubed. Note that we don't change anything about the inside function, except change the t to x. Let's try this again. Here it says to find the derivative of g of x equals the integral from x to 3 of 7 over t plus 1 dt. Here, we almost have an accumulation function. We can almost use the first fundamental theorem of calculus. The problem is that the x is on the bottom and the 3 is on the top. Thankfully, we have a rule for definite integrals that allows us to flip the boundaries, interchanging a and b, but to do that, we have to put a negative sign out front. We rewrite g of x as negative the integral from 3 to x, 7 over t plus 1 dt. Now we can take the derivative using the first fundamental theorem of calculus. So we get g prime of x is equal to negative the inside function changing the t's to x's. So we get 7 over x plus 1. Now let's try one that's a little bit trickier. Here we're asked to find the derivative of h of x, where h of x is the integral from 0 to x cubed of 17 cosine of x dx. Here, this one is also not quite an accumulation function because of the x cubed. And in fact, the way we want to think of it is a composition. We have some accumulation function, f of x, which is the integral from 0 to x of 17 cosine of x dx. And now h of x is equal to f of x cubed. So if we want to take the derivative of h of x, we want to take the derivative of f of x cubed. And to do that, we need to use the chain rule. So the chain rule says we take the derivative of f, we plug in x cubed, and then we multiply that by the derivative of x cubed, which would be 3x squared. So then the question is, what is the derivative of f? Well, f here really is an accumulation function. It's an integral from 0, a constant, to x. And we want to take its derivative in terms of x. So we can say that f prime of x really is, using the first fundamental theorem of calculus, 17, I'll finish this, 17 cosine of x. Why did I say uh-oh? Because in this problem, I've written it poorly. I'm using x to mean two different things. I'm using x to be the boundary at the top of the integral, and also the variable of integration. That's bad practice. So let's change these ones to t. That way, when we use the first fundamental theorem, we change the t's to x's. And we don't have to use t for the inside. This works just as well if you want to use any other letter that you want. How about, let's use y. Y is a good letter. But in any case, you use the first fundamental theorem of calculus if the boundary letter is the same as the function that you want to take the derivative of. So if we're taking the derivative in terms of x, and you have an integral from a constant to x, then we want to use the first fundamental theorem of calculus. So have we finished this problem? Not quite. We found f prime of x, but now we need to put that together. What we really wanted was h prime of x. So we have h prime of x is supposed to be f prime of x cubed, So f prime of x is 17 cosine of x. So f prime of x cubed is 17 cosine of x cubed times the derivative of x cubed, which is 3x squared. So here we've done the first fundamental theorem of calculus combined with the chain rule.